Hello and welcome to this lesson about surface area of prisms. The learning target for this video is finding the surface area of prisms and exploring the relationship between 3D objects and 2D representations. The last part might seem a little bit confusing, so that's where we're going to start. 3D and 2D. So what I want to do is first draw a rectangular prism, like this. And I want us to start thinking about what this prism might look like in 2D. So let's imagine that we were just going to take some scissors and we're going to cut it open wherever we can. And what we're going to end up getting is a shape that looks roughly like this. So we have these four pieces right here. I don't know if you can, my arrow is showing them all. And those have to kind of do with the, or these kind of like bigger faces of our rectangular prism. So let's start off with that top one. Look like that. Then next to it we have two skinnier ones that come from here and here. So that's what these are. Let's just kind of color those like that. And then we have another big one that's underneath it, which would be next to it, like this. And finally, we have our two little edge pieces. And so these would go right about here and here. Now, what we just did is we drew what's called a net. And that is one sec here, let me clean that up, 2D representation of a 3D shape. So essentially what we're doing is we're cutting it open and we're laying it out flat. Now think about this. Many of you have probably had to break down a box at some point in time, especially like an Amazon box or something like that, where your parents would say, hey, could you go put this in recycling for me? And when you're ripping open that box, you're taking a 3D option or a 3D object and you're putting it into 2D, 2 dimensions. That's kind of what we have going on here with nets. And what that helps us do is it helps us kind of piece together how we're going to find the surface area. So the surface area is simply just equal to, so we'll call it SA, the sum of all the, we're going to call them faces, or sides of an object. And so let's take a look at two options and how this is going to kind of break down. Option number one, let's go back to our good old friend, the rectangular prism. Draw it like this time. Okay, so this rectangular prism has a length, a width, and a height. And what we have are three different sort of faces to it. So we have this first one. You have to remember that the height is also here. And so if we were to take this first object, its area is going to be length times height. There we go. Then we have our second object, or our second face, which is right here. And that one's going to be, has dimensions width and height. So the area of this one is width times height. And finally, we have this guy on the top. And this one has, so the L applies to it here as well, and W goes right there. So the area of this guy is going to be width times L. And then what we're going to do is add all these up. But before we do that, we have to remember that essentially there are three other faces on this thing that we can't see, three other sides. So, and they're all mirrors of the objects we have here. So we're going to have another one of these, we're going to have another one of those, and we're going to have another one of these right here. And so what we're going to do is ultimately just times these all by 2. Oops, let me use different colors. And then we're going to add them all up together. And that's how we find the surface area. Okay, so now let's make this a lot neater, because this doesn't look all that neat. So surface area is equal to 2 times length times width plus length times height plus length, oops, my bad, width times height. So we just have to make sure that we pair all those three dimensions together you can then multiply them individually and then add them all together and times it by 2. So let's do some examples. So for our first example, let's say we have a rectangular prism and it has dimensions 5, 6, and 8. So we're going to apply that formula. So surface area is equal to 2 times and then length times width plus length times height plus width times height. Now the thing is, it doesn't matter which one you pick. We've done this exercise before where we can rotate this rectangular prism however we want, and what becomes length is width, and then it doesn't matter what you put where, just as long as we're consistent. So what I'm going to do, surface area is going to be equal to 2 times, and then I'm going to go with 5 times 6 plus 5 times 8 times plus 8 times 6. I'm going to do all my little multiplication problems. So this is going to be equal to 2, and then I have 30 plus 40 plus 48. All right, now I can do the addition inside my parentheses. So that's going to be 2. Let's see here. So 30 and 40, that gives me 70. I'll add 48, and so that's 118. Times that by 2. Let's see, that's going to be 6. I carry a 1, 3, 236. Now, this is going to be in units squared because we're talking about area, not volume. Okay, so it's units squared. And again, what we're doing is we're imagining, how much paper would be needed to cover all of this. How much wrapping paper, if you did not have anything overlapping, would be needed to cover all 6 sides of it. All right, now the other thing I want to point out before I do another example is notice how we have this funneling down of work. That's how this is going to work. We have to do a lot of little small problems and bring it together. We come to make peace with the fact that it's a bunch of small problems. We're going to be consistent at getting a right answer. Now, let's kick things up and talk about a triangular prism. So, let's see here. There we go. All right, now, triangular prisms can be a little more tricky to kind of piece together here. All right, so let's say that we have 3, 4, 5, and then let's just keep counting, call that 6. All right, so for the surface area, we have the net's going to look a little bit different. So we have one rectangle that is 5 by 6, and that comes from this guy right here. We have another rectangle which is down here on the bottom, and this is going to be 3 by 6. So 3 by 6. And then we have one final rectangle, which is from this back side that we can't really see. So it's behind the triangle right there, and it's 4 by 6. So 4 by 6. And then finally, we have our 2 triangle pieces. Each one of these, I had to draw it into the right triangles. Each triangle is a 4 by 3, 4 by 3. So what's difficult is with triangular prisms, we have to kind of wrap our mind around that we're not going to have things double up as much as we do with the rectangular prism up here. But again, if we understand what surface area is, it's just the area of all the different faces, we can break it down piece by piece like we're doing right here. And so now I just have to find all these areas and add them up. So 5 times 6 is 30, 3 times 6, 18, 4 times 6 is 24. This one is 4 times 3 times half, which is 6. 4 times 3 times half, so 4 times 3 is 12, times by half is 6 as well. And now, add them all up together. So let's see, I have 6 plus 6, which is 12. And then 12 plus 24 would give me 36. Over here, I'll have 48. And then let's see here, I'll get 84 when I add that all up. And again, it's going to be units squared, not units cubed, because we're talking about surface area. So let's wrap everything up with a quick little conclusion. So first thing, let's talk about nets. And what that is a 2D drawing of a 3D shape. And if we open up these 3D shapes into 2D drawings, we've turned this into a composite area problem or a compound area problem. Surface area is equal to the sum of all the areas of the shape. So we look at each side of the shape, we find all the areas, and we just add them all up, and that's it. So good luck with your homework or practice, and let me know if you have any questions.